So, good evening, Europe, good morning, US, good morning, Miami. Today, we welcome you to another lecture in the frame of the module Emerging Fields in Architecture. In the lecture series Extreme Architecture, we have Alfredo Muñoz here. He is a colleague of mine of the Technical Committee for Space Architecture of the American Institute of Aeronautics and Astronautics. And he is also the leading architecture of a widely published design for a city, a self-sufficient city and sustainable city on Mars. I guess you will hear more about it in a few minutes. The Future World is an ecosystem that leverages virtual reality and blockchain technology to create digital twins of extreme environments. That results from the work of global experts in space architecture, including Alfredo, of course, but also arts, deep tech, sociology, blockchain, and the space industry. Also, Alfredo Muñoz is the founder of the ABIBOO Studio, which is a global design firm. The studio provides services to Fortune Global 500 conglomerates, to government institutions and private clients. He is busy on 5 continents. You will also hear a little bit more of his work style in a few minutes. And Alfredo has been recognized as one of the most influential Spanish architects and also as a young European leader in his field. He has offices in the United States, in Spain and India, and in all these 3 offices, he leads a multidisciplinary team that again works interdisciplinary and merges art, technology, sensory experiences, and also anthropology to create unique and meaningful architectural spaces. Alfredo, thank you for joining our studio tonight. Please let us know about your work.
Very good. Thank you so much. Thank you, Sandra. Hi, everyone. Let me share my screen. Okay, hopefully. Do you see the first screen that says Emerging Fields in Architecture, Sandra?
Perfect.
Fantastic. Very good. Okay, so my objective for today is to expand on a personal journey that hopefully inspires some of you of fields that are not that common in architecture that could be relevant for your careers. And that expands on the concept of emerging fields in architecture, right? So my objective is to talk on a personal journey that took me from Madrid, where I am originally from, in Spain, to Mars. And in between, we're going to be talking about some different areas in architecture that might not feel obvious to some of you, but that were critical for that personal journey that I explained before. So let's get into it. Before I started ABIBOO Studio 12 years ago, I was working in Japan with Toyo and in New York with Skidmore, Owens & Merrill. So I had the fortune to work on really large-scale projects across the world. But then in 2010, when I started ABIBOO Studio, which means the beginning of creativity, combining Latin and Japanese, I started to do traditional work in residential in Spain. This project that you see here is a very large home for a football player from Real Madrid. That was the first project that I did, and it got diversity of awards. But again, it was more coming from a traditional approach to architecture, right? Like how we can solve the villa for an individual in Spain, in this particular case. We continue doing some diversity of work also in residential. This particular one is also in Madrid, is for the former Microsoft president of Spain. And again, residential, we try to obviously focus a lot on creating exciting solutions and innovating, but still it was on the residential villas, pretty common for our field in architecture, right? We continue doing some more work also in Spain. This particular one is a villa in a very old town where the entire town has to be clad with stone. So we try to reinterpret the traditional construction in stone solutions. But again, a villa, small in this particular case, it was not more than 300 square meters. Then we started to do some more work for villas as well in different locations. This particular one is a villa in Los Angeles, in California. And that's where I'm going to start going from a more local approach to architecture to how we started to take a more global approach. And that, again, bear with me because I want to start talking about different fields that might be interesting for your careers. The thing that then that led is for us to start doing more work abroad. In this particular case, you can see a high-end residential project in Kuwait City. We have done a diversity of projects in the Middle East. But again, residential, nothing that from the typology point of view is too different from what we are used to in the architectural field. But it started to grow our practice abroad and in a diversity of cultures. This particular case is in Bolivia, in La Paz, in the capital. And one of the things that started to be clear to us as we were working internationally is that it was critical to work in multidisciplinary teams. And this particular project is a tower in India, in Bangalore. And back to what I was saying about multidisciplinary, when you have the opportunity to work on large-scale projects internationally, not only it is essential to rely on a local architect that helps you to understand the code, but also to work with engineers and experts in the local culture. For example, in this particular case in India, a Vastu, which is similar to Feng Shui, is essential for the way of understanding architecture, right? So when you are exposed to locations that you are not very familiar with from the cultural background, because I was from Spain, and despite I knew India, it was not very straightforward. It is very, very relevant to start to work on how we adapt, how we bring our understanding of architecture from our teams and our backgrounds through the professional career that we all have, and how we need to almost forget about everything we know and start thinking in adapting to that particular location. And that is some hints that you probably are starting to identify on how all of these learning opportunities are going to be useful when we go on a very extreme environments like those on Mars, right? But back to international work, we continue doing a diversity of work. In this particular case, is a high-end residential combined with the hospitality, also in India, in this case in Pune, close to Bombay. More on the affordable side, affordable and low-income housing as well in India, different project in Calcutta where we did the design for entire township. And this was the first time that we had to consider not only the approach of how the locals live on a micro level, in this case on a building, but on a macro, right? We had to design 300 acres, which is a township for 200,000 people. Then you start to consider urban planning with the criteria that I mentioned before, how to adapt to a culture that is so different to ours in Europe or in the West, right? And again, if you look at how to design a building, obviously there's a lot of differences, but if you look at urban planning, the level of impact that the local culture has in the actual approach to urban planning is essential. So that is where, again, I would like to insist on working with multidisciplinary teams and locals that understand the culture, right? Then we did another master plan for another township, in this particular case in Chennai, also for affordable housing. But then we started to do some more high-end projects. This case is a mixed-use development. It has a residential tower and a hotel in Pune as well, close to Bombay. Then we did some work for elderly homes in Japan. But then an opportunity came thanks to that global exposure of having Louis Vuitton as a client. And that led to another interesting learning opportunity, which is how partnerships can help to grow the professional practice. And the truth is that for us to be able to partner with Louis Vuitton and have them as a client have opened a lot of interesting doors that I will explain a little bit later. Our work with Louis Vuitton was exposed in every single storefront of Louis Vuitton across the world. And that, again, led me to have a very fascinating understanding of how in architecture is so common when we are talking about multidisciplinary work, having engineers, having consultants, but it's not that common to try to partner or to work closely with other institutions that are really well established. And that is something that is an opportunity as an architect to grow into different areas of the field, right? Additionally, the work of Louis Vuitton was connected to digital art. And I will circle back later to digital because it's very connected to space architecture in many ways. But one of the opportunities that we saw with digital is the scalability. In architecture, we normally create one prototype every time. That means that it's very difficult to scale, right? We have a client, we create the design for a house or residential project or museum, it doesn't matter. But every project is very unique to that particular location and to the needs of the particular clients that are going to be using that building or that city. But with digital, it opens the doors because now one single design can be highly scalable. And that is somehow connected to the metaverse that I will explain later. But in parallel, we were also opening another doors that are connected to emerging fields in architecture, which are temporal structures. Some of you might be familiar with Tomorrowland. It's a music festival in Belgium. So we created some designs for them for the accommodation in Tomorrowland that require rapid deployment. And that is also an opportunity in our fields to work with solutions that require a very fast implementation and sometimes that might be needed in remote locations or in areas without a lot of infrastructure. These are some of the interiors of that project. The construction systems that we created, we filed for patents, and we also implemented it in situations for emergencies where we don't have a lot of possibilities to bring materials due to maybe the roads are cut because of floods or hurricanes or any type of natural disaster. And then those construction systems can be even erected without the need of a crane. And we created in this particular case was for the disasters that happened in Puerto Rico during the hurricanes. But that opportunity to create rapid deployment structures also led to starting to think how those solutions or those systems could be implemented for hospitality. This is a project in Ireland, in Wicklow, for a very small boutique hotel that implements the same solution that I mentioned, but then deeply integrated with nature and with cork as the facade that also enhances the thermal performance, right? And that connects to something that is very critical when we talk about extreme environments, which is the relationship with nature. Our work on rapid deployment structures and that possibility to erect buildings or solutions that can be very remote allow us to start to be very passionate about construction systems that allow that solution. So this is a project in Alabama, in the US, that was erected in 6 months. The construction was with engineered timber, and this was for music and festivals connected to the project in Belgium that I explained before. In this particular case, was to provide the food and beverages next to the auditorium in Huntsville. But here, where we start to be interested in is in how to merge that architectural elements or objects with nature. That led to another project here in the US, in Washington, D.C., where we were asked to re-envision how a mall could be reconverted to a new way of creating a relationship with nature and with the shopping experience. This particular mall was one of the largest malls in Washington, D.C. area, and it was empty. And we were working on how we could create almost like an internal garden in the mall, and how to bring technologies connected to hydroponics and aquaponics to create a very calm and relaxing experience, and at the same time bring the traditional approach of markets in Europe to the large malls that are very common in America. That led again to working closely with companies that were specialized in hydroponics and aquaponics that allow to create cultivate vegetation in indoor environments. Well, that led to creating projects for bankers, emergency bankers. This particular project is in South Carolina. And again, now you probably start to see a transition of some of these ideas and some of these technologies that are leading to how they can be implemented in space architecture. The solutions that we have to solve in bankers are not that different to those that we have to face on space. We have a contained environment where we don't have exposure to the outside, and I will talk much more obviously once we talk about Mars. But we have also the need to create a relaxing environment and a linkage with nature that cannot be exposed to the outside either. So how we can ensure and guarantee that the environments that we create are not only ensuring that we survive from the physical point of view, but if we have to stay 3 months to a year in that enclosed environment, how we ensure that the psychological aspects of architecture are guaranteed. And that is also very connected to that relationship with nature that I was talking before. This is another project, in this case, as well for bankers, but it's a modular solution that can be transported and erected anywhere in the world because it fits inside the container. Well, that led to designing solutions that are getting closer to the traditional term of extreme environments. This is the MDRS in Utah, and we have designed the interiors for the project. The project has been, many of you might have heard about it. It's probably one of the most famous space analogs in the world, and I will be talking about the space analogs later. But for those of you that don't know, space analog is basically a simulation of how we are going to be facing very extreme solutions on space. So instead of launching a rocket and putting our astronauts at risk if something goes wrong, we first test those conditions on Earth. So we look for environments that are very harsh, that are facing situations that could be similar in gravity. There are some space analogs under the ocean, very extreme in regards with temperature. In this particular case in Utah is pretty close in some situations of some of the temperatures that we will face on Mars, and also the terrain is similar. So the MDRS is an opportunity to test and to simulate some of the limitations and extreme conditions that we will face on Mars. But the MDRS is a project that was built many decades ago, so it requires some work internally. So we were asked to design the interiors, and it's a small project, but 8 people, sorry, sometimes from 6 to 8 people usually go for 2 weeks to work as a team on creating that simulation of how a team of 6 or 8 would survive on Mars, right? So we did, it has 2 floors. We did the ground floor and the interiors, and is currently going to be starting the renovation. Okay, so that takes us to Mars. Once we have discussed different paths from approaching architecture on a very macro level globally, to looking at the digital environments, from exploring temporal and rapid deployment structures and how the integration with nature can help to get our field into emerging areas, how we can bring that nature indoors, and how that opportunity bring us to ensuring that we can have not only the environment to physically survive, but also to thrive when we cannot be exposed to the outside because of harsh conditions. Then we have a lot of opportunities to take all of that learning and take it to Mars. But Mars, as I will explain in a few minutes, it's extremely harsh. And obviously, a lot of the conditions that we face on Mars require that we start thinking from scratch and that we adapt back to what I was explaining before. So I'm going to first show a project that we were working on Mars, and then I'm going to go the rest of the presentation explaining in detail on some of the solutions that we took from our experience working with global experts in astrobiology, life support systems, engineering, sociology, and all type of fields that we thought were relevant for creating a realistic solution on how a Mars colony would be. So let's first check a video. Hopefully you can see it properly. It's just a couple of minutes. So this video is a simulation of how we envision a capital on Mars. Okay, so Mars offers a lot of challenges, and I'm going to summarize some of them, and then I'm going to explain you how we envision an architectural solution that could overcome some of those challenges. Well, the first challenge we have is radiation. Anyone exposed to the sky on Mars would very quickly develop cancer due to the gamma and solar radiation. So we need some type of materials on top of our heads, and I'm going to keep it very low level. I don't want to go into too many technical terms, but at least on the big picture, because this is going to help to understand how, by solving the problems on Mars, not only we are going to be identifying opportunities for that particular planet, but also more importantly, we are going to learn a lot of interesting insights that then can be back applied to Earth. So again, back to what I was saying about the radiation, anyone that is exposed to the sky will basically die very, very quickly. So we need to have either a lot of thick material on top of us or go underground. There are a lot of other challenges, like the impact from micrometeorites. Again, we don't barely have atmosphere on Mars, so that means that anyone that could be walking around in the surface could be hit by a micrometeorite, right? Or a building could be hit by a micrometeorite and then get depressurized. Another challenge that we have on Mars is the pressure. While we have a gravity of 1/3 of Earth, which means in concept that we could go with very large structures because we don't have the problems or so many problems regarding gravity. So we could technically or in theory go with big buildings. The truth is that that is not possible. The reason for that is the pressure. Humans need around 1 atmospheric pressure to breathe. We can bring it as low as 0.7 bars, but we cannot go below that. But the atmospheric pressure on the surface of Mars is 100 times less. That means that the pressure that we will have inside the buildings will be almost 100 times bigger than the pressure that we have outside the buildings. If we go with buildings that are on the surface, that means that the amount of resources and structural performance that we will have in the surface of those buildings will need to be so high that will make it unfeasible from the economical and logistical point of view, especially if those buildings are very large, because the pressure is exponential. The more the volume is, the bigger the volume is, the more pressure we have. That means that either we go with very small buildings, or we have the risk that that building will explode almost like a balloon when we inflate it too much. Well, then what we created is 2 phases for development. And the first phase is where we are envisioning that in the next 20 years, we might be able to have a small settlement on Mars. It depends a lot on how we are able to get people from here to Mars. And all of you might have been reading a lot of the news that the SpaceX is doing. So we are optimistic that in the next 10, 15 years, we will be able to get to Mars, and then we will potentially create a small settlement. That small settlement, we are targeting what we are calling Mars City Alpha. And again, all of this is a hypothesis. There could be many other solutions, but those solutions need to be solving the challenges that I explained, and I will continue explaining. So this first phase is what you see on the screen, is what we are calling Mars City Alpha, is a small development that accommodates up to 400 people. And those buildings are a combination of 3D printed structures with geodesic domes. The 3D printed structures need to be very small. Why? Because, as I explained, if they are large, the pressure will be too high. The advantage of 3D printed structures is that they allow to be erected with the regolith or the dust that we have on the surface of Mars. But it's not very sustainable because the buildings, we cannot reuse them. Once they're built, right? And we cannot adapt them easily. At the same time, we really need to rely on robotics and artificial intelligence to create those buildings. But some of the challenges that I mentioned, like, for example, the radiation and the impact from micrometeorites, can be a question mark with those type of solutions. So the way that we are solving it is by adding another structure, which you saw here, which is steel structure that overflies those small buildings. The advantage of steel is that on Mars, we have a lot of iron and we have a lot of CO2. With CO2 and water, we can get carbon, and with carbon and the iron, we can get steel. So based on the work that we have been doing with the experts in different fields, seems like steel is a material that could be obtained locally. That goes to another concept that is essential on Mars, that is self-sufficiency. While on the moon, we can rely on resources from Earth because it's so close to us, and we can always send things back and forth. It requires a lot of resources, but technically it's possible. On Mars, it is not possible because the orbits are very different. That means that we have only a window of opportunity to send things back and forth, or humans back and forth, approximately of 1 month every 2 years. That's probably why some of you might remember in the movie The Martian that Matt Damon gets stuck over there. The reason for that is that they were missing the window of opportunity, and then they had to come back. And if they didn't come back at that particular time, they had to stay 2 years in the planet, right? So the complexity of Mars offers a whole new opportunity that the moon doesn't offer. And from the space journey point of view, obviously the first stop is going to be the moon, and then in the next frontiers of civilizations, once we are able to establish some type of settlement on the moon, we will be able to go to Mars. But from the theoretical point of view, Mars offers and demands the need to think much more aggressively in the terms of sustainability and self-sufficiency. So when we look into any approach that we do long-term on Mars, we need to think how the materials that we use and the solutions that we use can be done with local resources, and sending as little infrastructure or sending as little materials as possible from the Earth, so that a colony or that settlement can actually be properly implemented. Well, the first thing that you see, and this is again Mars City Alpha, what you see is the 3D printed buildings that I was explaining before, but then we have geodesic domes. The advantage of geodesic domes is that they are very easy and fast to install. The problem that we have with geodesic domes is that the skin will be exposed to that challenge that I mentioned about the internal pressure. So it is not really efficient and feasible to create geodesic domes on Mars on the surface if humans are going to be inside without the proper equipment. So many of you might have seen some solutions that are going in that direction. From our personal opinion, they are not really realistic. The reason why we are proposing geodesic domes in this scenario is just for farming. Why is that? Because the pressure that plants can have, especially when we go with aquaponics and hydroponics, don't require that much pressure. We can solve it at 0.4 bars. That means that now the skin of those geodesic domes does not have that constraint or that much layer of resistance as we need when humans are going to be able to breathe. So in concept, all of those geodesic domes and these farming areas, for humans to be able to be inside, they will need to be with the proper equipment. Well, another advantage that we envision of that large canopy that I explained before is that, as I mentioned, humans cannot be outside in the exposure to the sky on Mars for a long time. But Mars offers beautiful landscapes and definitely very different to what we are used to on Earth. So from the artistic point of view, or even architectural point of view, it feels that there is a sad not to leverage the possibility that humans can walk with equipment. Remember, the atmosphere is not breathable on Mars and the pressure is too low. So we need equipment to be able to walk outside on Mars to be able to breathe. But if we are protected from the micrometeorites and from the radiation, then we can create a small micro protected environments where people can breathe normally inside the 3D printed buildings. All of those 3D printed buildings are connected underground so people can walk, and they can go out with the proper equipment to be able to walk a little bit in the Martian landscape, to be able to see the rest of the horizon because they are protected from those canopies, and then to have small parks and farming areas for the plantations. Here you see a view of one of the parks that I explained. And remember, these parks have very low pressure, so they cannot, humans will not be able to stay without the proper equipment or for long periods of time, because it's almost like if you go suddenly to the Himalayas without enough oxygen, right? So you won't be able to survive. So this is the challenge that we will face by being in these environments, but allows to still have the possibility to create a lush environment where the nature starts to be part of the experience of these future Martians. Well, another concept that I want to emphasize is we still don't have scientific data of the long-term impact of low gravity environments on the body. We know that it definitely has a negative impact on the body. You probably read recently that there was an astronaut that spent a year in the International Space Station, and when he came back, he could not walk. So all of that we know, but we don't know what else can happen. We know that there could be an impact on the vision, but the truth is that for those that are going to travel to Mars, they first need to spend around 6 months traveling to Mars in a low gravity environment, because there is no gravity. We can try to generate artificial gravity in the ship, but that's science fiction. The truth is that if we are going to use the technology that we have now, that is probably going to be as proposed by SpaceX, we will not have gravity in the spaceship. Then we are going to land to Mars, and then we will have 1/3 of the gravity that we have on Earth. So that means that the body will not be able to be back on Earth. But this first settlement that we are talking about, that we are envisioning to a maximum of 400 people, the objective is that those people can come back to Earth. So how we can solve that problem is something that the scientific community still don't have an answer. We are thinking on how we can generate artificial gravity centers. This particular one that you see here, it's a collider structure that rotates. It has 60-meter diameter, and it turns 4 times per minute, and it generates a similar gravity when you are inside rotating in that collider to what we will have on Earth. But there's still a lot of ifs of what will happen when those people that travel to Mars need to come back to Earth. Another thing that I want to mention is you probably recognize this element as something off, right? Something odd. Well, from the very beginning, we want to ensure that we create an environment that creates an identity. We don't want just to solve the life on Mars. Obviously, that's the first priority. We need to ensure that we provide every level of protection for those that are going to be exposed to the harsh environment on Mars. But how can we create identity for those that are going to be there? How we create a sense of belonging? How we can bring arts and land art into the small experiences that they will have? Well, here, for example, from the design point of view, we were thinking, well, Stonehenge is one of the oldest monuments that we have on Earth, right? And at the same time, you probably recognize the shape of Space Odyssey 2001, right? So we were thinking, well, although we are not going to be able to walk around a lot outside, this is something that can be part of batteries that are bringing some type of reminiscence of the culture on Earth from the very beginning. And that is, again, very important when we are trying to solve a settlement on Mars, how we create that sense of identity and belonging through arts, through architecture, through fashion, as I will explain later, that ensures that they are proud of where they are, and either for a certain amount of time or long-term, as I will explain in the next phases of development that we are envisioning for Mars. Here you can see the interiors of those 3D printed buildings. Again, this is a hypothesis. There are many solutions out there that you probably have seen. The truth is that the first settlers on Mars are going to live very tight. What we are envisioning is almost a solution where those first settlers are living similar to how the capsule hotels are in Japan, right? So you can see the small buildings again that have the different sleeping quarters, and then other ones, as I explained, that have the areas for relationships and entertainment and working and research and development. And these are the areas that we are envisioning at the top of the sleeping for socializing and relationships, right? But the truth is that while I explain, and again, I went very fast, and I want to keep it on a very high level so we don't get too technical, but while we do think that 3D printed buildings with some type of protection with canopies is a good solution for small settlement, The truth is that if at some point we want to have a large-scale settlement on Mars, the 3D printed solution is probably not the most feasible. Why is that? As I explained before, the resources that will require by taking all that regolith and then being able to implement it on the surface and then not being able to change it and requiring a lot of those 3D printed buildings that cannot be big because of the challenges that I mentioned before is something that doesn't seem very feasible. So what are the options? Well, the options are to go underground. If we go underground, we solve many challenges that 3D printed buildings don't still have. Some of those challenges are the temperature. On Mars, even if we are in the equator, we can have very extreme temperatures that go with temperatures as low as minus 100 degrees centigrade, similar to how we have in Antarctica, even at the equator. That means that the amount of resources that we will need for humans to be comfortable from the thermal point of view are so high that it is not feasible to lose that thermal comfort through a skin that is exposed to the outside atmosphere. Additionally, we have the challenges, as I was explaining before, that the solutions have to be very small. So we cannot envision a community of 10,000 people living in super tiny environments because at the end, they will feel really constrained, right? So if we go underground, the advantage that we have is that all of those solutions are solved. We are protected from the sky, we are protected from the micrometeorites, we are protected from the loss of temperature, because if we are underground, the mass of the land around us is absorbing or keeping the temperature inside. And also now is where we have the opportunity to even work with the pressure from the inside. Because if we have large environments inside that are pressurized, also the rock or the terrain, if we are underground, it's absorbing that inner pressure. So there are a lot of advantages of being underground, but there are many disadvantages. Obviously, the lack of light. That is a very important factor that we need to ensure that we solve. Well, on Mars, there are lava tubes that could be a very interesting option to consider. Especially if we are going on a large settlement, as I explained. But what we envision is an opportunity to go on the side of the cliffs. Mars have really tall cliffs, and they're all over the planet. So in this particular case, where we proposed the first large-scale settlement is in the cliffs of Tempe Mensa, which is in an area that has a lot of water in the surface, below the surface. We have good temperatures, and there are a lot of advantages regarding access to minerals and important elements that we will need. But one of the opportunities that we have with going on the cliffs is that we can create a three-dimensional net of tunnels. Those tunnels ensure that we can bring a tunneling machine from Earth that can fit in the spaceship, and then basically with the tunneling and the reinforcement of steel, we can create, through obviously artificial intelligence and robotics, a highly dense solution. Why is that? Because on the sides of the cliff, we can create a three-dimensional web that is very compact, which is critical for ensuring that we limit the amount of resources that we use. Anything on Mars have to be transported because we have nothing over there, right? We don't have any supply chain, we don't have anything. So ensuring that every logistic and every system that we create, including energy, including food generation, including transportation among humans, including all the different activities that we could envision for a large community on Mars requires, have to be very compact. So there are alternative solutions, for example, in craters. But the disadvantage of craters is that it's not very dense. While, as I was explaining, there are a lot of cliffs on Mars, and many of them are really tall. I mean, we are talking that in this particular case, the cliff is 1 kilometer high, which is higher than the Grand Canyon in the US. But there are many that meet that particular requirement. And also the opportunity that this type of intervention on the site allows is that it can be very compacted, as I explained, which helps for planetary conservation, which is an idea that a lot of scientists are talking about, that they want to be sure that even if we create some type of settlement on Mars or settlements on Mars, which probably is the path to go due to resiliency, create 2 or 3 different settlements that are far from each other. So we have a resilient system. So if something happens in one settlement, we can always have the community go into another safe environment, but still the rest of the planet should be maintained untouched. So the power that we have with a very dense solution is that that approach to a planetary conservation can be achieved better than on other architectural solutions. But also, as you can see in this image, it creates a very spectacular view. Imagine yourself being in the walls of the cliff, looking at the Martian landscapes, the red skies or blue skies. If it's during the sunset or sunrise, is the opposite as here on Earth. And to have that sense of belonging that I mentioned before, we think it could be extremely relevant for a long-term community. What we envision is that we have that web of tunnels that I explained before. They can be that go as deep as 250 meters in the cliffs, but then perpendicularly to the tunnels, perpendicular to the walls of the cliff, we have what we are calling a green dome, which is a park which has less pressure than the inside environments where we have the living quarters. This helps to create a buffer zone from the security point of view, because remember, the outside pressure is almost non-existent. It's 100 times less than what we will have inside. Here we will have 0.8 atmospheres, but here we will have 0.4, 0.5. So first, we bring the light indirectly in, which help us to ensure a comfortable environment and a long-term a guarantee that humans are going to live in environments that are psychologically acceptable. But at the same time, we are totally protected from the harsh outside environment. And any relationship or any visual relationship that happens between the living quarters and the outside is always through nature and through small parks. Obviously, the natural elements, we will need to bring the seeds from Earth in order to implement them on Mars. But you can see here an idea and a view of how those green domes or those small parks connected to the residential quarters are. Well, the opportunities here as well from the architectural point of view is to study the buffer zones, right? Like, where are the limits of the landscaping horizons of Mars, and where are the limits of the influence of our culture and nature that we bring from Earth, and what are the limits of the actual environments that are purely Martian. And from the poetical point of view, or even academic point of view, it is fascinating to start looking into how the limits blur, right? Well, here you can see the common areas that are connected to the living quarters. And that also brings to a very important topic to discuss. That is, how are we going to live on Mars? Architecture should adapt to the context. I was talking before, we need to adapt to the environment, but it's not only adapting to the physical environment, it's adapting to the social environment. When we go to work on Bolivia, we don't do the same designs that we do in India or that we do in Kuwait City. So we need to understand the culture, but we don't have yet a culture on Mars. So we need to visualize and work closely with experts in sociology and a lot of different fields that I will summarize now some of the ideas that are discussing about how we will live on Mars, because the architecture has to adapt to that way of life. But not only that, architecture is going to enhance the specific way that communities live. So it's a bidirectional relationship. Does architecture adapt to a social context, or the way people live in our cities and in our environments changes the way we relate to each other? So question for all of you to think, probably you might agree that both directions are there. So the question for all of us is, how are we going to live on Mars? Well, the truth is that Mars is extremely harsh environment, the lack of resources, some of the challenges that I mentioned. That means that life is always at a threat. We are always going to be in danger to die. So we believe that if the communities on Mars are going to focus on individual gains and individual experiences, the chance of that community to implode is going to be substantially higher. So what we believe is that Mars is going to require almost like a communal way of life, where the community is supporting and living, thinking also in taking care of the community. There are a lot of examples of this type of approaches in Japan and in other parts of the world, where the community members are more important than the actual individual. And that, as a European or as an American or as a Westerner, is something that we might have a difficulty even envisioning, right? But the truth is that if you put yourself in a highly extreme environment, like let's suppose on a war or on a mountaineering through the very complex peak in the Himalayas. Well, if I go with Sandra to climb the Himalayas and we are going together, and suddenly I decide that I want to do my own thing, not only am putting Sandra at risk, I am putting myself at risk as well. So when we are in extremely harsh environment, the community building is as important as guaranteeing that the physical environment is covered through the proper architecture and engineering solutions. So how we create a society that ensures that the community members are looking after the rest of the community members. So if you take care of your neighbor and you know your neighbor is going to take care of you, the chance of that society to implode and put everyone at risk is lower. In that regards, what we are envisioning is that in order to live on Mars, we need to create a urban and architectural environment that is going to support strong bonds and strong human relationships among the communities, where the common areas are some of the most important architectural aspects. So there is strong psychological bondage between the members. That almost leads to thinking, and again, all of this is a hypothesis, but we believe that the life on Mars is going to be almost like a communal or a co-living environment, where we have the common areas are basically the core of the time spent as a community, and obviously a lot of work that I will explain later, and a lot of different activities that the community will have to do. But any type of relationship will be mainly focused on members building. You can see some views here of those tunnels. Here on top, you can see what we are calling pods. The pods are the individual units. The individual units, obviously, we are humans. We also respect and appreciate individuality. We want to be sure that everyone have a space to rest and be with themselves. So what we are creating is a unit or pod we are calling is a 25 square meters each that is modular. This is essential to create a scalability. So we are proposing those pods that are made of solutions in steel back to the resources locally, polymers is not feasible on Mars. There are a lot of different materials we explore, and the opportunity to create solutions that are highly scalable, all of them the same, that are modular, and at the same time, they are able to connect with each other is something important. These modules that you can see here, they can be connected, and then if one individual is part of a family, then the family has different pods, and then they can create a combined a home, let's say that way, right? But you can see the size of the units are pretty small. We're talking about 25 square meters per individual, while the common areas are indeed the spaces that ensure that you're forced to go out to create emotional bonds with your community. You can see here the insight of how we are envisioning a potential pod for one individual, right? Here, the opportunity as well is that we will have to do a lot of activities for maintaining the artificial intelligence and the robotics and the communications with Earth. But we mentioned before that we have a strong challenge regarding the low gravity. We have, as I mentioned before, 1/3 of the gravity on Mars. So even those that potentially be permanent living on Mars, which is how we are envisioning this more long-term community on the cliffs, while the first settlement that I explained before, we are thinking that's why we have that collider that I explained, the possibility that they might be able to be back on Earth. Here, they're truly Martians. We're envisioning that you go to Mars and you stay on Mars, and we still don't know if we will be able to have children on Mars. Again, a lot of ifs, but we are based on the assumption that considering the challenges that we will have coming back to Earth, if we want to create a permanent establishment, a community on Mars, it has to go and stay. So there still gravity is going to be an important challenge. So what we are envisioning is pods where not only you perform your work and activities, which I will explain how important they are regarding the energy generation, but also you have a belt where you can walk while you are working, and you can exercise and work and control the different type of infrastructure that will be connected to Mars. And this connects to the relevance of energy. Okay, so there's a very interesting book called The Energy Return of Investment. And it talks that at the end, societies have been able to do well and create resources for their communities because we have been able to outperform the energy that we generate versus the energy that the human takes. So this book talks that in order for a community to have some type of advanced organization like we have in many countries in the West or in other locations, we need to generate at least 10 times the energy that a human requires. And that's why we can have education, we can have healthcare, we can have culture, because the basics are covered, and yet we are able to generate additional layer of energy. Well, when we were working with a team of experts for creating the data that we needed for Mars, the truth is that Mars, because it's much more a harsh environment, and we need to generate oxygen, we need to generate everything from scratch, and we have to obtain the energy mainly from the sun, but it's much farther from the sun. Truth is that on Mars, we have also dust storms that are long-lasting, so we cannot only rely on the sun. And again, the sun is farther, so we cannot obtain so much energy from the sun as we obtain here on Earth. But the truth is that we need approximately 10 times the energy that a human is able to require on Earth. That means that on Mars, to have the similar lifestyle that we would have on Earth, a human will need to generate 100 times more the energy than one person will require, which is completely unrealistic. That's where we start to understand that not only AI is going to be essential, and robotics, and to be able to develop a very sophisticated technology that allow us to have enough energy to be able to live on Mars, but also the answer is that we will probably not be able to have the lifestyle that we have on Earth. And that also brings an interesting insight. Earth is very forgiving. We can change our environment very quickly, and we don't really see the impacts until years to come, sometimes decades, sometimes generations. And we are seeing some of the results in climate change and social inequality that we have today in our environments, in our social environment and physical environment, right? Well, the truth is that Mars very quickly shows the impact of our actions. And we will be able to quickly understand that we cannot change our environment based on our will, like we have been able to do on Earth and we are used to. We need to start thinking that in extreme environments, we need to adapt and change our lifestyle to that harsh environment. Otherwise, we won't survive. But again, remember what we were talking about the social relationships, how much social pressure, how much social conflict is going to generate when lack of resources, potential concerns that one person might create trouble that could put the entire community at risk, as we explained before, is going to add to the already complex and difficult environment that we have on Mars. So to be able to be very effective with the local resources is something that is going to be essential, right? At the same time, we will have to think of transportation solutions inside the community that are extremely efficient. And here we are proposing again some conceptual approaches of how we could use different hyperloops to communicate the different inhabitants inside the web of three-dimensional tunnels that I was explaining before. But farming is going to be one of the most important and critical aspects. We need to eat. If we don't eat, we don't survive. So what is the diet that we are going to have on Mars? Well, when the astrobiologist and life support systems team were working with us in creating a simulation of what was required for Mars, the first answer that was very obvious is that the amount of energy that animals require to be alive, to breathe, because we need to generate that oxygen, to build the space of those animals to be, and then we eat them, proportionally, the amount of energy that we get by eating animals is not worth the energy that we need to keep them alive. So the answer was that on Mars, we will not be able to rely on eating animals to survive. That means that the diet will be basically based on crop, microalgae, insects, cellular meat potentially, and maybe on a very, very special occasion, some type of a small animal like fish or little animals that we might be able to bring from Earth. But that also brings a fascinating insight. When we analyze the amount of space that we needed to generate that nutrients that humans for a large-scale settlement on Mars needed, we realized that we needed approximately 100 square meters per person for areas related to food generation, okay? And as I explained before, because we didn't have, or we could not have a lot of space for animals, most of it was focused on cultivation of crop through hydroponics and aquaponics and insects. Well, if we look at the space that now we use on Earth, you will be shocked. Currently, we use 6,000 square meters per person on Earth for crop and livestock. So that means that if we go, obviously, on a very academic level and very big picture, if we compare the potential areas that we need on Mars, which is extremely harsh environment, we were able to solve it in 100 square meters. On Earth, currently, we are using 6,000 square meters. That is 60 times more. If we are able, again, on a very academic level, to solve the challenges that we face on Mars in 100 square meters, and that was using high-level technology that could be also more complex and more economical intensive than what the type of farming that we use. But imagine if we reduce the amount of meat intake that we currently do, that means less space for animals to be required because we will not be eating them. And we take the technologies that we currently have through vertical gardens and aquaponics and hydroponics to create a more advanced technologies for farming. We could liberate a lot of space that then can be used for reforestation, which we know is the most efficient solution to reduce the CO2 from our environment. So what I want to, and probably you're starting to see a lot of topics that by us as humans being able to envision how we are going to live on an extreme environment such as Mars, and starting to think from scratch by analyzing the data that we have and thinking outside of the box, we are being able to do things differently. If we take that learning and we are able to implement it here on Earth today, we can actually start to solve a lot of the problems that we know we have on Earth, connected to climate change, social inequality, differences in even more extreme that we are going to see due to population growth in the next 20, 50 years. So we don't need to wait until we go to Mars to solve problems on Mars or problems on the moon or situations on low orbit and connected to a space architecture to start learning from the insights that we know are going to be required if at some point we want to live in an extreme environment. So that connects to the space utilization. I mentioned that from the urban point of view for crop and anything related to food, we needed around 100 square meters. Well, for the entire environment that is not regarding energy, so that means crop and the living environments, we need a total of 225 square meters. That means that any space where humans will be able to interact with each other is reduced to around 125 square meters. We did an analysis on counting Manhattan or Hong Kong, including the streets, because obviously in here on Earth, you can walk around in the streets because you can breathe. On Mars, those environments need to be generated, need to be prepared for humans to be able to walk and interact with each other without the need of special equipment. So we analyzed that Hong Kong or Manhattan are approximately the same level of density per person if you count the parks and the cities and the streets and the buildings that we have. So if we compare apples with apples, on a long-term colony or settlement on Mars, where we are thinking that could be more than 10,000 people living, the density is very, very similar to those that are currently on Earth that are extremely dense. That connects also to how we are using the space here on Earth. We are used to, especially in some cultures like in the US, where everything has to be big, right? We have homes of 200 square meters, 250 square meters. Do we actually need that much space as a family? Can we start to visualize how our lifestyle is affecting our environment and how if we do small changes, each of us, as architects, obviously we have, or as engineers, we have a higher impact on how we affect our environment. But it is very important also to understand that there are small things that we can start doing from envisioning how we are going to have to live on an extreme environment like Mars to be able to learn from it and start doing changes to our day-to-day lives, right? You can see some visuals of the hydroponics that we have. Okay, how is going to be commerce? And that is something that connects to another emerging field in architecture, which is connected somehow to what I'm explaining in extreme environments, but is also connected to the digital environment that I mentioned before. Well, I explained in the beginning of today's talk the concept of a space analog. Just to repeat it, space analog is a simulation in a safe environment that creates a similar situation of something that is dangerous. So if something happens, we are safe, nothing, we don't have a potential harm to those experimenting that analog. Well, truth is that while space analogs are very relevant and interesting to analyze physical conditions, how are we going to create a simulation of the complexities of society? When we do space analogs now, we basically talk about the small groups. I mentioned, for example, in the MDRS, it's usually 6 people. Different space analogs are a contained amount of individuals that the focus is mainly on the physical environment, the very hard situation, how you handle it, right? But what happens when we have to deal with a community of 400, 10,000, 20,000 people? The conflict resolution. What happens when suddenly the resources are such that require to have a very difficult situations for those communities? How is going to be trade? How is going to be commerce? How is going to be politics? Are we going to have a different type of political structure on Mars that maybe we have not even considered or envisioned here on Earth? How is going to be the distribution of resources? We talked before, humans are per se individual in nature. We have seen it. Models that try to go on a highly communal solutions have failed across history because humans are individual. But we mentioned before that if we only think on the individual as the core of society, the chance of that community to implode is very high. So how are we going to provide the encouragement for every individual to be able to do what they think they can bring the best to the community and yet be able to control the differences? That is connected to economy, that is connected to politics. Well, that's where current technology offers a great opportunity, because if we mix virtual reality and blockchain, we can create simulations in the digital environment that are somehow space analog for large communities. So if we are able to create an environment that is very realistic through virtual reality and create an economical and political simulation where through blockchain it's control, I mean, it's not control in the sense that we know who did the interaction, but everything is traceable. So although it is anonymous, we can analyze from the scientific point of view every single interaction that happens in that community. And at the end, politics and governance is the architecture of power. So how we analyze the relationships among the communities that will happen in extremely harsh environment, especially when we're talking about big communities, is something that has not been done yet. So how we can bring the digital technology into the space architecture and space solutions to learn in a safe environment how things are going to be, and potentially learn from something that we think is going to work and then suddenly it implodes and everyone dies. Well, thanks to being in the digital environment, fine, game over, start again. We create the simulation back to zero, and then we start creating and obtaining data, because the truth is that human nature is not going to change that much, although we will probably have to adapt and even transcend who we are as a species if we actually want to survive in a large settlement on extreme environments such as Mars. Then again, how we create the economy, how we create the relationships that are going to allow to bring that community to thrive internally and to even interact with those here on Earth. So what we envision is to create a currency that is based on energy. We call it the power unit. The power unit is somehow a currency that is linked to how much energy that community is able to generate on that extreme environment. So the more energy as a community that we are able to generate, the higher wealth that community has. And if you guys are interested, we can talk a lot about that. We have people that were experts in economy and in blockchain and in sociology and in politics to try to understand that relationship through the blockchain of how we can link the economy and the governance through one solution that helps to understand and simulate that potential environment. But here also, as architects or as designers, opens a lot of doors, emerging fields in architecture. Well, how can an architect provide value in fashion? Well, the truth is that in an extreme environment like those on Mars, we cannot consider that fashion is going to be the same way that we have here on Earth, the same way that art is not going to be the same way, right? Like, back to resources, what type of resources will we have in our hands? Considering that we need to be self-sufficient, we need to take whatever is available, and there are a lot of things that we cannot do on Mars. And also the scalability, back to the concept of scalability that I mentioned before, how we can ensure that we can generate enough clothes for the community in it as cheaply as possible and as long-lasting as possible, and yet be able to provide a sense of identity and belonging for everyone to be able to self-express through fashion, through art, through their environments, right? So here, for example, what we were envisioning working with experts in fashion as well is how we could create almost like an androgen solution where female and male and anyone living in the environment on Mars has almost the same type of clothes, but then we create that customization through accessories. Even those accessories are made of steel that help to bring a little bit of weight to the body to try to help slightly to that low gravity environment that we will have on Mars, right? So again, back to the question that I started today's talk, from looking into a traditional architecture to how we can look into global solutions, to then exploring digital as a way to scale and to provide something that is very easy to transfer from one place to the other, to temporal structures and rapid deployments that force us to think on low resources and remote locations, to how nature brings a critical aspect of bringing us as humans close to a proper physical and emotional condition to thrive. How we can bring that natural experience in the inside environments. How all of that can be applied to extreme environments here on Earth, and how we can take all of that learning to space architecture. And finally, here to finish today's talk, now we have the door closed. How can we open that not only we can solve those problems on a extreme environment in the space, but how, by solving them, we can open the door to directly implement a lot of the insights that we can have to start solving the problems that we have here on Earth. So with that, I am all yours for any questions that you might have.
Thank you, Alfredo. Yes, I think it would be great to talk a bit more about what we can learn from space architecture, extreme environment architecture for projects on Earth. We have a few questions in the chat. Let's go through them first. Marlene.
You are muted, Marlene.
My first question was related to the heat and the relation to steel on Mars, but you kind of talked about that later. So the other question I would like to ask you is, what are the architectural lessons we can take from Mars and translate to Earth, most of all to Earth in extreme environments?
Oof. So I mentioned a few of them, like back to resources and materials, for example, right? The concrete, we use it a lot on Earth, is not very sustainable. We use a lot of polymers and plastics that are not very, I mean, they provide a lot of value to communities because we created a lifestyle that is forcing us to always push the limits of how or what we can do to change our surroundings. But if I go back to what I was saying, first is how we can start thinking that we can do a big impact, positive impact on our environment if we do small changes in the lifestyle, connected to diet, connected to the space requirements, connected to the materials that we use, connected to how we interact with each other to improve the level of relationships that we have, that we're not that close from living in a harsh environment. I mean, if things go the way they are going in 50 years, a lot of parts of the world are going to be pretty harsh to live, right? And that's going to bring a lot of social conflict and a lot of migration that is going to add additional layers of conflict. And so to look at how we need to solve current conditions on the space or future conditions on the space, because the conditions are extremely extreme, is something that directly has a fast application today on Earth. Yeah, I went very high level. I mean, we can go on very detailed, even on a micro.
So one more question. What area on Earth would you now apply this knowledge you've gained to? So what is the first place you would say this is where we can use it?
I would say probably the impact on farming. It has been very impactful to me as an architect when we were working with the astrobiologists and the life support systems guys, and they were telling us that the amount of space that we use here on Earth is 60 times more of what we could do. It was, and I'm from Spain. I love meat. I'm like, you, man, you cannot take my meat out. But since I am aware of that, I start to reduce the meat intake because now, from the scientific point of view, I understand the impact that I'm doing, right, on the environment. And that's something that sometimes you hear politics talking about it and, you know, whatever, or sometimes scientists. But when you are actually understanding in detail the impact on how we could liberate a lot of space for reforestation, is something that is quite relevant as well. Another thing that had an impact on us on a day-to-day basis is how we approach design. I mean, in the university and as an architect, we always thought like, okay, architecture is so connected to community building, right? And to responding to communities. But sometimes we forget. We like design and we try to always focus on creating something that is interesting as a design point of view. But over the last few years, especially since we started to do or be much more involved with space architecture, I think we value more the community building even more than the design side, right? Like we focus sometimes more, it's like we don't really care if the design is not so innovative and it's not going to be in architectural magazine or whatever fancy magazine is going to be there, because maybe we are not taking the design so much in the field to the next frontier, but more like humble, trying to look at how by the designs we do can improve the relationships in the communities, is something that had a big impact in our day-to-day practice.
Okay, thank you so much. It's very interesting.
Cool, my pleasure.
Marlene, do you maybe have another question concerning your work? I know you have a very specific work that we talked about today, and because Alfredo works also in India, I would take the chance.
Yeah, so I wanted to relate space architecture to architecture in farm and rural areas in Bangladesh, but the connection was kind of hard for me to grasp how important the things we just learn from space, how important can they be on Earth? So maybe do you have any input on that?
Mm-hmm. It's fascinating. I mean, Bangladesh is different culture than in India. As you know, 50% of the population in India is vegetarian, which is connected to what we were talking about food, while Bangladesh and the north of India is not so much. It's a mainly Muslim community. So it's not that common to have vegetarians in Bangladesh. So that's something that obviously looking at the culture, it will be important. The technologies that I mentioned about aquaponics and hydroponics and highly high-tech technologies, which could not be applied realistically as of today in low resources environments like Bangladesh, right? So how you can work with efficiency into crops that are more efficient than others, how you can add solutions that potentially can be beneficial, like insects or even microalgae that are already proven to work, is something that could be interesting to explore. Space utilization, I mean, you are mentioning more about farming, so farming is what it is. You require the space if you cannot use high-level technologies. But back to lifestyle, I mean, it's already super dense. I don't know if you guys have been in Dhaka, but it's the most dense place I have been in my life. It's crazy. So it's already very, very dense, but it's dense without the proper architectural quality of environment, right? So how we can maintain that density, which is less than 25 square meters per person for sure on the living environments, but how we can create spaces that enhance or facilitate that density, but with the proper quality of architecture and urban context and infrastructure. I mean, there's barely infrastructure even in Dhaka. I mean, I remember walking in mud all the time. There was basically no infrastructure whatsoever, right? So again, it depends a lot on if you are looking into a more futuristic solution or you are looking into an actual solving problems now in Bangladesh, then the lessons from space architecture could be different. But I would go back to the space utilization.
Okay, thank you so much.
My pleasure.
Thank you both. We may have one question by Eric.
Yeah, thank you. My question would be like in a wider way, who wants to live on Mars, or who do you think are the people who are going to live on Mars? Because yeah.
Sorry, I interrupted you. You wanted to add something else?
No, I just wanted to ask to say that in my mind, just like scientists and people who are curious about the living conditions, like tourists or other people, could imagine to live in an atmosphere which is like not compared to the human nature.
Mm-hmm. There will be a diversity of type of people that I envision that could want to live on Mars. Obviously, first ones are scientists and people that are interested into putting themselves at the limits of what is possible for humans to take humanity to the next level. But there is a lot of other people, like why people want to live in Siberia or in Antarctica or in areas that are very harsh, right? And that goes back to intrepids, to adventurous people that feel like they don't have anything to lose and they want to try something else. And they feel like experience to the core of who they are as humans is more important than safety, right? There are not going to be people that are very concerned about safety because the chance of them dying is very high. But it happens also. Why do people do skydiving? Well, I mean, if you look at safety, probably you wouldn't be doing skydiving, but that's part of who we are as humans, right? Like that, always pushing the borders and the limits of what we can do and what we cannot do. And the truth is that the combination of experiential searchers with the scientific community could lead to a lot of insights. I mean, we don't know what we don't know, right? And when we are exposed to actually having to create a community and a community that makes it. I mean, taking people to Mars is going to be probably feasible very soon. The question is, are we going to be able to create a community that can thrive on Mars without imploding? That's a whole new animal, right? And the truth is that there will be people that, again, might be very interested in going. Based on the analysis that we discussed with the experts, there cannot be older people. Anyone over 30, they won't be able to travel to Mars. They won't have the stamina, the strength, and the adaptation capability to travel. So they will have to be very young people with a lot of with very little fear not to make it.
Okay, so thank you. So it's going to be more like short term.
Not necessarily. As I mentioned before, we are envisioning a lot of problems of short term. Sorry. The reason for that is the gravity. So once you go to Mars, we don't know if you come back, if you will be able to walk, or even if you will be able to survive because of the impact on the gravity, the low gravity environment on the body. You might go blind, and get a lot of situations that can happen that the scientific community has not yet answered, right? But the truth is that in our hypothesis, again, a hypothesis has to be proven, and it's just one hypothesis among many. We are looking into two phases. One of them is short term. That's what we're calling Mars Village Alpha for 400 people, more or less, which is pretty large, where we are envisioning a potential short term for 2 years, 4 years, come back. And then the next one, which is really where the challenges come, is on a permanent human settlement on Mars.
Okay, so the thing with the 30 years old, it's just for the traveling to Mars?
Yep.
Or is it all for the living? So if you travel with 20, you can live there
again.
Longer.
The assumptions based on the data that we now have is that it's such a harsh environment that the body needs to be at the peak of the physical conditions, even to travel. Again, 6 months without the low gravity, without the gravity, and then you show up to Mars and you have so many difficulties there. As I explained, some of them won't be able to. A body that is older and not in their peak of their physical condition might not make it. But all of this is just wishful thinking or hypothesis that we still don't know. Unfortunately, maybe in 10 years we do. Today is yes, but we probably don't want to send people that are not at the peak of their physical condition, because the chance of them not making it is even higher.
Perfect. Thank you.
Thank you. We have one question from YouTube. Madeleine Ottoman has the following question. Hello, can I ask on what does inspire you to create these kind of buildings on Mars? And what does inspire you in finding the design concepts and design languages for the interior?
I could say, like, relationship with nature has been always very relevant for us in the team and for me personally. To work in the team, in a very large team with very, very collaborative solutions, right? Again, when we started working on these solutions for Mars, we knew some limitations, but we were not able to know in depth what were the challenges. For example, I was not aware that one of the main problems on Mars is the pressure. Like, everyone is thinking, oh, the radiation and all that stuff. But then to me, it was interesting surprise to realize that the fact that the buildings will explode instead of collapse is very interesting too. And that came through a lot of conversations with experts in astrobiology and planetary geology and life support systems. Again, we work with more than 30 experts. And by having a lot of conversations with them, a lot of the ideas as an architect come together. So in a traditional practice, I usually say to our clients that architecture is almost like psychology. You need to bring and ask a lot of questions and try to understand what happens, and then through that information, convert it into a space, right? So in our case, being able to talk to so many people from different fields was very interesting, because we need to start start to visualize how that community was going to live. And then once you understand how the community is going to live, you start to think what are the problems that they will have to face. For me, it was always very important to create a sense of identity. I have always been fascinated with cliffs since I'm a child. So the moment that they told me that there were a lot of cliffs, I was like, wow, that's the answer. Because there's a lot of conversations in the past of going underground on Mars. That's something that has been around for a long time. But the idea of going underground and yet being able to be in direct light, I think it was very, very fascinating for me, because it came automatically, because it was like obvious. It's like obvious if you cannot go, if you cannot be on the surface and you have to be underground, but you need to bring light, and there are a lot of cliffs. I mean, that's and then talking to people, experts in mining and planetary geology, they were confirming that indeed that was a very, very feasible and interesting solution that could scale, right? So talking to people, relationship with nature, creating a sense of identity and belonging, I think that happens throughout any type of design that we do, because it's part of, from my opinion, a good part of architectural good design. And then obviously to work with resources and ensure that this self-sufficient, which is part of the needs that we have. It was not just because of this hype about sustainability. No, on Mars you need to. It's no other option.
Thank you, Alfredo. We have one more question that's interesting from Marina.
Hello. I wanted to ask, how would you define the term sustainability? And do you think that the research on how to live on Mars could help us to rebuild a sustainable future on Earth?
Mm-hmm. Thank you. So for me, sustainability is about leveraging to the best possibility the resources that we have. And it's not only about environment, it's about economics too. It's about the social effort that we use or implement to create something around us, right? So yes, the environment and the impact on the materials we use, etc. Sure, it's part of sustainability, but I think it's much deeper than that. And that is something that space actually forces us to do, because I mean, indeed, there is not that much resources out there in the space, but the economy or the economical aspects are even more relevant in many situations, right? Like how to create solutions that can be scalable, that can be as efficient as possible, yet being able to accomplish what we need, not only from the physical point of view, but also psychological point of view, is something that is very important. And back to your second question, how we can learn from space architecture and space solutions. I mean, I think I kind of briefly mentioned some topics, but the truth is that, yeah, when we are forced to create an environment in an extremely harsh context, where resources are limited, where the economical situation has to be very effective, where the energy is not available, we need to think out of the box, right? And sometimes innovation happens by answering something different to the same question, but sometimes it comes when you ask a completely different question, right? And I think space architecture offers the opportunity to ask a completely different question, because we are forced to. And then as a result, the answer is going to be different. And some of those answers could be applied to Earth, some might not. But those that can be applied to Earth are potentially going to be different to the answers that we would be getting if we just look at the problem of how we are going to solve sustainability on Earth with the context that we normally look at when we are not looking into space architecture, because it's a completely different question. We don't even have to think of problems of gravity here because we gave it for granted, or we don't have to think of oxygen because we give it for granted. We don't have to think of pressure because we know what the pressure is. So there are a lot of things that we don't need to think about supply chains. We don't need to think about politics and economy because we give for granted that that's what we have, right? But when we are actually having to think everything from zero, there are a lot of potential opportunities to do. And this is going to be this is a decade journey, but the beautiful part of hypothesis is that then you put something out there and see if it sticks. If it does, you continue developing. If it does not, then you go to some other new hypothesis, right? That's scientific method that has proven to work.
Okay, so there are a lot of researchers and a lot of development, but do you see it happening in reality? So is there actually something happening today, or do we expect that it takes longer, so more time, something to happen?
To happen, you mean the space?
Yeah, space and actually on Earth as well.
Oh, I mean, there's so much information and transfer of know-how that happens from the space industry to Earth. I mean, the one that you are probably more familiar with is GPS. But there's so much technology that is transferred from space, from MRIs to GPS to pens. I mean, it's like countless technologies that we give for granted today that come because of the space industry. I mean, I can't remember the exact detail. I think it was 6-1 that there has been research is done that every dollar that is invested or every euro that is invested in the space industry returns 6. So the return of the investment as humans that come due to the space advancement is substantial.
Okay.
And that has been going on since we have been in the space journey.
Thank you.
Pleasure.
We have one question by Carolina, sorry.
Yes, so first of all, thank you for the interesting presentation. And you talked a lot about the simulations you're doing, so and the importance of digital on the digital world to make these scenarios. And my question would be, if you think, because outside of research, maybe it should be also important to take these messages to the people, to like regular people. Do you think that films like The Martian could help to make people understand the lessons that we could translate back to Earth and that we have to make changes?
Definitely. Like anything that allows to educate through doing is something that I think it has a lot of value. The digital environment that I was mentioning can be adding into that direction. Like if we have at some point the simulation accessible to anyone and they can interact and then create those social relationships that I was talking about, and then they need to spend to buy a burger on Mars, on the simulation on Mars. They want to buy a chicken burger, they need to spend 10,000 power units. But then if they want to buy a cucaracha burger just for the sake of, it costs 3 power units. Or if you want to buy a vegetarian burger, it costs 1 power unit. Then you start to question, it's like, how is it possible that for me to buy a chicken burger is 100 times more expensive? I'm just making the number up, but just conceptually, than to buy a veggie burger, right? So by learning through experience is something that then you can take all of those experiences to your day-to-day life, right? Same with entertainment, as you're saying. I mean, the impact of movies or games into the day-to-day life does have an impact. And it's funny because when we talk to people that are not in the field and we talk about Mars, the first thing they talk about is The Martian, which we are having close relationships with Jim Green, who was the former chief scientist in NASA, who was very closely involved with the Martian movie. And it's funny because, yeah, that movie, for example, had a very interesting impact on the day-to-day life of people that are not in the field. And they're like, oh, that would be possible. And would you plant tomatoes or potatoes or how? So anything that has the possibility to make complex information understandable and easy to implement on a day-to-day is definitely welcome. And we're working in that direction. Again, it depends a lot on resources on every level, right? To create an scalable simulation requires a lot of resources, but there are many different avenues that as a civilization we can take to bring some of these ideas more to the general public.
It seems like a playification, like if you talk about yes.
Yeah. I mean, the concept of gamification is taking a lot of traction in education. EdTech is leveraging a lot of these ideas of gamification. If you, for example, look at Duolingo, right? Like you learn and then they give you points. It's like this idea of gamification is really taking a lot of traction in the education industry, because sometimes people learn by doing, and there's no right or wrong answer, but everything helps, right?
Thank you.
Pleasure.
Thank you. We have one final question again from the chat. The question is, as an architect, he or she wants to know your opinion on the notion of being reserved and employing classical industrial design approaches, for example, from shipbuilding, versus the opportunity to design exotically for mass. It's hard to understand, but I guess he wants to know if we can draw on some other lessons learned from Earth for extreme environment.
So the question is, how can we learn from classical architecture to be implemented in space solutions? I'm not following very well the question. Sorry, Sandra.
The question is opinion on conventional permanent habitat. If we can learn from industry workers and the use of classical prefabrication methodologies for Earth, for example, Earth cargo ship building.
Got it. I mean, what I'm taking from the question, and sorry, whoever asked the question, if I'm not fully understanding the angle that you were trying to ask, but what I'm taking from it is, like, for example, shipbuilding, you mentioned, well, that is industrial, that provides a highly scalable solution, right? And usually in many, I mean, it's changing, but still, architecture sometimes is always creating a prototype every time. I mentioned it in the beginning of the talk, right? And it is tricky. I mean, as architects, we are still very deeply influenced by the ideas of the Romanticism, where we think that architect has to be an artist and everything has to be unique. But the truth is that not necessarily. And when we look at resources, sometimes the fact that things are not easily scalable require more resources, not only from us as architects to create it and conceptualize it, but also to implement it in construction or for the client to pay for it, right? So how we can create solutions that are scalable, that are allowing that serial production, yet still be able to provide a unique experience is a question mark. And obviously, we have been trying to answer this question since the modern movement, right? So it's not a new question, but thanks to technology and thanks to the current lack of resources that we have in our industry, because it has changed a lot since 2008, I think there are more and more initiatives going on providing architectural solutions that can be replicable and scalable, similar to the containers that you asked about. So there's a lot of opportunities to learn from the serial production for architecture. Definitely, we need to go on a large scale intervention on extreme environment like the ones I explained for a large colony on Mars. We need to go serial. We cannot rely on every single unit being different, because it's not realistic, it's not possible. And we need to basically rely on manufacturing chains of artificial intelligence and robotics to do it. So that can only be done if we take it to a whole new level of manufacturing.
Thank you very much, Alfredo. Unfortunately, we are at the end of your talk and the Q&A. I thank you for telling about your project and bridging the gaps or the questions related from space to Earth and what we can learn from both environments. The last question fitted very well into it. It was very interesting to listen to you, and you showed that it is worth to look at extreme environment architecture, even from a theoretic point of view, because we can learn a lot for our real life here on Earth.
Well, I hope you found some value in today's talk, and I'm around. Let me know if anyone has any questions. You can reach us at our website, abiboo.com, and then we'll be happy to answer any questions, or ask Sandra, and then she will give you my contacts.
Thank you very much. So please take the chance if you have a question, and have a good day, Alfredo.
Have a lovely evening, all of you.
Thank you.
Thank you so much. Bye-bye. Cheers. Bye.
Thank you.